Hello, this is Rishik from iBot, the robotics hub of IIT Madras, and this session will be a quick guide to parametric modeling, assemblies, and rendering in Fusion 360. But before that, let's quickly go over the solution of the toolbox I showed you in the last video. To make the toolbox, firstly, select the Create Sketch command and select either the ZX plane or the YZ plane. Now, once you are in, select the two-point rectangle and make a rectangle of dimensions as shown. Once done, select the line tool and enable the centerline line type, and from the center of the top edge make a center line. Press escape to finish. Now select the line tool again and make a triangle as shown. Once this is done, remove the center line, add a fillet of radius 25 millimeters. Now draw a circle of diameter 25. Once this is done, press finish sketch and extrude it. Extrude it by 20 millimeters. Now, on the front face, create another sketch, which is going to be another two-point rectangle as shown. The width is around 20 millimeters. Once done, use the extrude command and extrude it by a length of 180 millimeters and ensure that your operation is set to new body. Then use the move and copy tool by pressing M on your keyboard. Select the body, enable the create copy option and move it to the other side. Press OK. Now use the move and copy tool again and select the initial body that you have created, and as you might have guessed it, we are going to move it by minus 200 millimeters and press OK. Once done, go to the bottom and create another sketch, which is also going to be a two-point rectangle. Press finish sketch, select the sketch and extrude it. Now to finish, we'll add the handle. So turn on the visibility of your first sketch and then select the hole and then extrude it by minus 180 millimeters. Now your toolbox is ready. Now that you know the basics of sketching and modeling, let's take it a step further using parameters. But before that, let's understand what parameters are and why exactly it's useful. Take the toolbox that we have created just now. Suppose I want to change the thickness of the handle, the length and the breadth of the entire toolbox. How would you do it? As of now, the best way would be to edit in the timeline, going to the respective sketch and extrusion and editing it one by one. But that's time consuming process. Parameters solves this. So under the modify drop down menu, you'll find the change parameters option, which lets you create parameters and use them later on. Under the model parameters, Fusion already automatically creates parameters based on the sketches and extrusions that I've performed. So let's say I want to change the length of the uh, toolbox. For that, I would have to change multiple parameters, which is still not exactly what we want, and it's kind of confusing since none of it are named. So let's get started with parameters. To begin with, let's create a nameplate using parameters and see how parameters will help us change its dimensions later on. Firstly, select the center rectangle and make an outline as shown. And one of the easier ways to make a parameter is to directly set it when you are assigning the dimension. So in the dimension box, just type the length and breadth and assign it a value. For example, base width, and I want it to be about 50 centimeters and press enter. Now when you do it, under the modify menu, you'll find the change parameters, and under the user parameters, you'll find the parameter that you have just created. Another way to make parameters is using this menu itself. Just click on this plus symbol and type the name of the parameter, which is base length, set the units, and enter the expression. And I want it to be about 150 centimeters. You can notice how this states expression and not value directly, so you can perform math here as well. I can use the base width parameter and multiply it by 3 since I want it to be 3 times its width, and press OK. After that, use the dimension tool and select this line and type the parameter, and you should be able to see it in the suggestions that Fusion tells you, and press enter. Now if I change the width of the base plate, the corresponding changes will be made in the length as well. So let's say I want it to be 65. So as you can see, the length has also changed. Now let's make a circle. Once again, you can directly set the parameter while assigning the dimensions. I want the radius 10 centimeters. But since the circle tool accepts dimensions in diameter, I will multiply it by 2. Now you can use this again and specify the offset from the side. I want the offset to be around 10 centimeters. And I want the height to be placed exactly at half of the base width. So what I can do is use the dimension tool again, select these 2 points and do base width divided by 2. So as you can see, now it's on center. Now mirror it to the other side as well. Let me make a construction line first. And press OK. Now this is done, press finish sketch and extrude it. So first let me change the direction to symmetric, and I'll change the measurement to the whole length. Now simply write the thickness of the nameplate. I want the thickness to be about 20 centimeters and press enter. As you might have guessed it, you can use parameters while using any of the modeling tools. So let me add fillets using the same. And let me use the radius parameter that I've already created and press enter. Now to finish, let me add my name on it. So create sketch and use the text tool and make a box over here and write your name. Press finish sketch, Then select the text, select the face. Size kind of looks off. So now let's use parameters that we have created to change it. Firstly, I would like to change the length, and I don't want it to be thrice of my base width. Manually type about 100. Now we'll move on to assembly modeling. Assemblies basically refer to how different parts or components of your design are related to each other to form the final design. A component is nothing but a container of all these sketches, bodies, joints, relationships, and maybe even other components that you create. By default, when you open a new tab or a new file, as you can see in the browser menu, you will be in your root component. To create a new component under the Assemble tab, press the New Component option and name it. And now press OK. This will create a new component, and notice the dot behind the component in the browser tab that indicates that the component is active. To go back to your root component, just click the Activate Component button over here. Another way to make a component is while you're using the 3D modeling tools. So for instance, here I have a rectangular sketch, and when I extrude it, I can set the operation to a new component. To name the component, just double click it and you can type the name. You can also make components from the existing bodies. So for instance, in the connecting rod and the piston example, I've made the connecting rod as a new body. What I should have done was make it as a component. To make it as a component from a body, right click the body in your browser and select create components from bodies. But this is not advisable to do, since when you do this, all the sketches regarding the component are still in the root component and you can't change them. Now we'll explore how different components are related to each other using joints. So firstly, here I have a set of three boxes, each of which is a separate component. Now, when I use a joint, it first asks me to select two components. And when I hover over any face of the component, I can see few symbols over here. The square represents the centroid of a face, while the triangle represents the midpoint of the edge. The circle represents the corner. So let me snap onto the centroid of the face, and I want the other joint origin to be the centroid of other face. Now I can change the motion type. When I press the rigid motion type, both the components are attached to each other. Using the slider motion type, I can make it move along one axis, and while using joint limit, I can restrict its motion further as shown. So now So now I can move the middle box in the set limits as shown. Now the revolute joint lets you rotate component 1 with respect to component 2 over the origins as shown. As you can see, the middle box is rotating over the first box over the point where I've snapped both of them, which is their centroid. The cylindrical joint gives you one rotational freedom and one translational freedom. Let me show you with an example. Here I'm snapping the centroids of the faces of the boxes again, and in the motion I can specify the rotation and the translation. And you can change the axis as well. But a point to notice that both the rotation and translation occurs on the same axis. So you can preview the motion as shown. So as you can see, it can rotate above the x-axis and move along it as well. The ball joint gives the components all the rotational freedoms but no translational freedom. So let me show you with an example. So now I can rotate it along all the three axes. The planar joint. Now I would highly suggest you to look onto the pin slot joint and the planar joint. The planar joint lets you move the component along a plane, while the pin slot joint is basically cylindrical joint, but the axis of rotation will be perpendicular to the axis of sliding. Now moving on to a few of the common relationships. The rigid group relationship locks the position of few of the components and makes them act as one singular component. So now these are a part of a rigid group and I can't move them. Another recently added feature is the tangent relationship feature. The tangent relationship basically makes a curved surface to be tangential to a face always. So now here I have a simple cam lifter mechanism. The cam part has a revolute joint as shown, while the lifter has a slider joint. Now when I apply the tangential, Now when I apply the tangent relationship, you can see that if I move the cam, the lifter is always tangential to that point. Now to apply what we have learned, we will be adding joints to this engine and see how it moves. I will also be providing the step file of this engine at this moment in the description below, so make sure that you try it out. But before that, ensure that only the support component is grounded and all other components are not. Once that is done, as you can see, along with the pistons and the connecting rod, I have created a pin and a crankshaft too. So firstly, grounding components ensures that its position relative to the parent, that is the root component in this case, is fixed. So we can't move the support component, but we can move all other components. Now we'll be adding revolute joints and slider joints. So press the join command and first select the cylindrical face of the crankshaft and next select the inner cylindrical face of the support. And once this is done, set the motion to revolute and press OK. Now for the connecting rods, select the inner cylindrical portion and then select the outer cylindrical portion of the crankshaft and then adjust the position. Press OK once done. Now repeat the same for all other connecting rods. I'll fast forward this for you. Once you have added the joints for all the connecting rods, now add joints for all the pins. For that, select the cylindrical face of the pin and select the cylindrical face of the connecting rod. Now, as for the pistons, select the circular face and then select the circular face of the connecting rod. And now as for the piston, select the circular face and select the circular face of the connecting rod. And for the piston, select the cylindrical face and select the cylindrical face of the connecting rod. Once again, adjust the position such that it's in the middle. Press OK and repeat it. Once again, select the cylindrical face and then select the circular part. Adjust the position. Once this is done, when you try to move the component, it doesn't move how you expect it. To solve this, we are going to add a slider joint as well. Yeah. So, on the top face, make another sketch. Make a 2-point rectangle and then use project command to project the outline of the circles of the piston. And make sure that you enable the projection link. Once this is done, press finish sketch and extrude it. Make sure the operation you set it to a new component. Now to add the slider joint, select the outline of the circle of the piston and then select the cylindrical face. Ensure the motion type is set to slider and you're good to go. Once done, hide the support that we have created and now as you can see it's moving as we intended it to move. Now let's move on to rendering. Rendering is the process when you convert your models into photorealistic images so that you can present it to someone. So to begin with, first navigate to your render workspace. Now the render workspace is pretty simple. You have limited amount of tools to work with. Firstly, let's go over the physical material. So physical material basically lets you change the default steel type to whatever you want. In this case, I'll add the plastic. So I'm choosing the ABS plastic and simply dragging it over. Now here, when you right click it and select the edit option, you can change the properties of the material such as density, or if you go in advanced and go to physical, you can change multiple things such as the coefficient of expansion, Young's modulus, Poisson's ratio, shear modulus, etc. etc. After that, once you're done editing, apply the changes and press OK. Then we'll move on to the appearance section. You can either click the icon over here or press A on your keyboard. This should open the appearance section. The difference between the physical material and appearance is that the appearance only changes the visual elements. It doesn't actually change the properties of the material itself. So we are going to add the plastic properties again. If you don't have the material already installed, you simply have to install it and then drag it over. Now here again, you can edit the materials and change its properties such as the color of it You can change its roughness or the reflectance, etc. Once done, press OK, and then you're finished. Now I would like you to toggle around with the appearance section, and next we'll move on to scene settings. Scene settings basically changes how you perceive the image. You can change the lighting conditions over here, or you can change the brightness, the camera FOV, etc., etc. You can also disable the shadows by unclicking the ground plane, or you can change the camera FOV as shown. You can change the aspect ratios, etc. And here again, I would like you to toggle with the menu, change the brightness, etc. Now let's move on to the environment library. This lets you add a preset lighting conditions. So if I add the cool light effect, the lighting conditions change, etc. By default, you should get a bunch of HDRI images as shown. These basically stand for high dynamic range images, which captures the lightning or lightning conditions or intensity of the image and then applies it to the model as shown. What I would like to suggest now is a website called as polyheaven.com where you can download a bunch of HDRIs and then apply it to your models. Now let's move on to adding a decal. Decal is basically a image that you can add on to your uh, model. So select the face where you want to add it, and now you can change the scale of it so that it can fit in a better way. You can rotate it, etc., etc. The chain face option lets it bend over edges as shown. If you disable it, it would simply cut. Once done, press OK, and now we'll move on to the rendering options. So firstly, the in-canvas render. This basically lets you have a preview of your render. It uses something called as ray tracing algorithm to mimic how the lighting conditions work so that it can show you the final output. What I would suggest is to leave it at least till 10 seconds to a minute so that you can have a better view. A point to notice whenever you have the in-canvas render on and you move your model, it will start all over again. And to avoid this, you can go to the in-canvas render settings and lock your view over here. Once this is done, you can't move the model. And as you can see, since now to render your model, select the render button over here. And now you can select any one of the presets that are already available in Fusion, or you can customize your image size, image aspect ratio, etc. And to finally render it, we can use the cloud render option, which uses Autodesk servers to render your model. And if you're having an educational access, then you should get a certain number of credits free where you can exchange it for rendering time. Or you can render it locally on your computer. The render quality over here depicts, it's pretty self-explanatory, depicts the final render quality of the image. If you are just testing it, I would suggest you to use the draft option, which will consume the minimum amount of time. For here I'm using the final option and then rendering it. Now you now you should be able to see this in your render gallery. It might take some time to render depending on your laptop, but once done, you should be able to preview it. So now you can download it and save it, etc. Now let's render the engine that we have created so that you guys can have a better understanding and do the same process, go to your render workspace. Uh, and this time I'm just going to add the appearances and not the physical materials since I'm not actually going to do perform some motion studies or simulations with it. So select the metal option. For the piston heads, add the brass polished metal. For the shafts, galvanized steel to it. And here again, you can change the roughness, etc. over here. And for the piston rods, let's add something else. Let's add, I don't know, maybe copper, platinum to just see how it looks like. And here as well, you can change the color of the materials. Let's add, yeah, something like this. Now close it. To have a preview, use the in-canvas rendering option and lock your view. So this is how it looks like. And now to finish it, select the render option and render your image. You should see this in your render gallery. Once done, preview your image. This might again take some time. And here you and now I would like you to create your own models using parametric modeling assemblies and finally render them. Once again, we will be providing the model of the engine in the description of the video so that you can download it. In the next session, we'll be looking on animations and motion studies, so make sure you're tuned in and subscribe. Thank you.